Most gardeners think plant growth comes from fertilizer. That's the mistake that keeps their gardens underperforming year after year. They dump pellets or liquid feed into the soil expecting miracles, but what they're really doing is bypassing the biology that actually drives growth. Plants don't feed themselves directly from fertilizer. They rely on microbes to process nutrients first. When that microbial layer is weak, you can pour all the nutrients you want into the soil, and plants still struggle. That's exactly why I decided to test something that Amish growers have quietly used for generations: fermented plant tea. Not the watered-down compost tea you see online, but a properly fermented microbial tea that actually multiplies beneficial organisms before it ever touches your soil. I ran it in raised beds, open garden rows, and even in a hydroponic setup just to see what would happen. The results were faster than I expected. And before we get into the method, if you're into practical growing techniques that actually improve yields and soil health, go ahead and subscribe to the channel now. This channel is built for growers who care about real results, not gardening myths. Most gardeners underestimate how much soil biology controls plant growth. When you dig into productive soil, you're not just looking at dirt. You're looking at a living system. Bacteria break down minerals. Fungi move nutrients through the soil. Protozoa cycle nitrogen so plants can absorb it. When that system is active, plants respond quickly. When it's weak, growth stalls. Fermented tea works because it feeds that biology directly. Instead of just adding nutrients, you're adding microbial life that processes nutrients for the plant. That difference matters more than most people realize. The version I tested starts with simple ingredients you probably already have around the garden. I used about 5 gallons of water in a bucket, preferably rainwater or dechlorinated water. Chlorine kills microbes, so if you're using tap water, let it sit for about 24 hours first. Into that bucket, I added roughly 2 pounds of fresh plant material. In my case, it was a mix of stinging nettle, comfrey leaves, and young weeds pulled from the garden. These plants are loaded with minerals and nitrogen, which microbes break down quickly. If you don't have nettle or comfrey, you can still do this with grass clippings, vegetable scraps, or even leafy weeds. Next comes the fermentation trigger. I added about 1 cup of unsulfured molasses. Molasses feeds the microbes and helps fermentation kick off quickly. If you don't have molasses, brown sugar or jaggery works too. The goal is to give bacteria a fast food source so they multiply rapidly. Once everything is in the bucket, I filled the rest with water and stirred it well. The Amish method isn't complicated. The key is letting it ferment long enough for microbes to break down the plant material. I covered the bucket loosely so gases could escape and left it in a shaded area. Within 24 hours, you'll already see activity. Bubbles form on the surface, and the smell becomes strong but earthy. That's fermentation happening. I usually let it go 3 to 5 days, depending on temperature. In warm weather, it ferments faster. This is where, honestly, many gardeners go wrong. They either apply it too early, before those microbes really have a chance to multiply, or they let it sit and rot for weeks until it turns, well, anaerobic. A properly fermented tea should smell strong, but not putrid. When it hits that point, it's ready. When I first applied this to my raised beds, I diluted it at about 1 part fermented tea to 10 parts water. This dilution really matters because, the concentrate is strong. Pouring it directly on plants can easily overwhelm those young roots. I watered it directly into the soil around tomatoes, peppers, and cucumbers. Within just a few days, the change was noticeable. Leaves darkened in color, and new growth really accelerated. That's not magic. It's microbial activity unlocking nutrients that were already sitting in the soil. The interesting part came when I tried it in hydroponics. Hydroponic growers usually avoid organic inputs because they can clog systems or create instability. But in a simple reservoir setup with strong aeration, a very diluted version of fermented tea actually stimulated root growth. I used about 1 tablespoon per gallon of nutrient solution. The roots developed thicker white branching structures, which usually indicates strong microbial interaction. I wouldn't recommend dumping large amounts into hydroponics, but small doses can introduce beneficial biology. Now here's something most tutorials won't tell you. Fermented teas work best when the soil already contains organic matter. If your soil is basically sterile sand or heavily compacted clay, the microbes won't have much to build on. In those cases, you need compost, mulch, or biochar to give microbial life somewhere to live. Speaking of compost, this is where, monitoring your compost pile becomes important. Temperature tells you whether the microbial engine is actually running. A healthy compost pile typically runs between 130 and 160 degrees Fahrenheit during active decomposition. If it stays cold, microbial activity is weak. That's one of the reasons I started using a long compost thermometer. It just removes the guesswork completely. The one I use is the RioTemp 20-inch backyard compost thermometer. It has a long stainless probe that reaches deep into the pile where the real microbial action happens, and the dial shows the activity zones, so you can tell instantly if your compost is steady, active, or running hot. I'm not big on pushing products, but tools like that genuinely help if you're serious about composting and soil health. If you want to check it out, I left the link in the description so you can see the exact model I use. So back to the fermented tea. The biggest benefit I noticed wasn't just faster growth, it was actually plant resilience. Tomatoes treated with the tea seemed to handle heat stress better, and, leafy greens kept producing longer into the season. I suspect the reason is microbial diversity. Healthy microbes compete with pathogens and improve nutrient cycling. That's something chemical fertilizers simply can't replicate. Another way I've used the fermented tea is as a foliar spray. After straining the liquid through a cloth, I diluted it about 1 to 20 and sprayed it onto plant leaves early in the morning. This introduces beneficial microbes directly onto leaf surfaces, which can really help crowd out fungal diseases. In backyard gardens, this approach works especially well for crops like cucumbers, squash, and beans that tend to attract mildew. It's not a guaranteed cure, but it definitely reduces disease pressure when used consistently. The trade-off is smell. Fermented tea is not something you want brewing right next to your kitchen door. The odor can get strong during fermentation, especially with high nitrogen plants like nettle. Keeping the bucket a bit further away from the house solves that problem. Another thing I've learned through testing is consistency matters more than concentration. Applying a moderate dilution every 2 weeks produced better results than one heavy application once a month. Microbial populations respond better to steady inputs. Over time, this method builds soil that becomes, a lot easier to manage. Beds that received fermented tea regularly needed less fertilizer overall because, honestly, the nutrients just stayed available longer. That's exactly what experienced growers aim for: soil that feeds plants naturally instead of relying on constant inputs. What impressed me most about this method is just how simple it is. No expensive inputs, no complicated equipment, just basic fermentation and a good understanding of soil biology. The Amish growers who passed down this method weren't following modern gardening trends. They were simply working with the natural processes that make soil productive. If you apply this consistently through a growing season, especially alongside compost and mulch, you'll start seeing the kind of soil structure and plant vigor that, honestly, most gardeners spend years trying to achieve. So if you found this useful and you want more practical techniques like this that actually improve the way you grow food, make sure you subscribe to the channel. And hey, share this video with another gardener who's serious about improving their soil, because the more people understand how soil biology works, the better food we all grow.